Well, I am Páll Einarsson. I work at the Institute of Earth Sciences at the University of Iceland and have been doing that for a long time, teaching at the university about earthquakes and geophysics, and also doing research on earthquakes and crustal movements and volcanic activity of the country. So I've been doing this now for half a century or so. So I'm going to go through some of the data we have on earthquakes in Iceland. It just so happens that we are in the middle of a very active period of the country, and people are feeling earthquakes now quite frequently, both in South Iceland and in North Iceland. And so it's a good idea to inform people and guests in the country about what is really happening. People might get worried when they feel earthquakes. There is reason to do that in most countries, but I will start by a comment on this. Keep in mind, if you get into the situation of feeling an earthquake, that most likely if you are inside a building, this building is not going to collapse. Our experience of quite large earthquakes in the year 2000 and 2008 tell us that Icelandic building practices are quite safe, and the earthquakes that occur in the country usually don't destroy houses. They damage, do a lot of damage, but houses are not going to collapse. And this is a very good thing to keep in mind when you are inside. The house you're in is not going to collapse on you. This is important because in most really fatal earthquakes, when people die because houses collapse on top of them. And this is the reason why in Iceland we have not had people dying in any earthquakes now for more than 100 years. So we go through some of the data we have, and just to emphasize, we have in this country a very sophisticated monitoring network to find out what is happening in the crust. And the reason for this is obvious from this map that you see here. This is the epicenters of earthquakes in the North Atlantic Ocean, in the North Atlantic area. And you see that these red dots and circles, they are epicenters. They show you where earthquakes happen, and at the same time where earthquakes don't happen. And they really paint up for you what we call plate boundaries. Iceland is in a very interesting place on the surface of the Earth, where two crustal plates meet, and they are drifting apart here. Western Iceland, most of Western Iceland, is located to the west of this boundary, that is, on the North America plate, together with Greenland that you see in the map, and also the whole continent of North America. Eastern Iceland, on the other hand, sits on the Eurasia plate, and that plate includes all of Europe and most of Asia as well. So these are two of the biggest plates on the surface of the Earth, and they are moving with respect to each other. And in Iceland, they are moving apart. So if you stand on one of the plates and you look over to the other one, it is moving away from you at a rate of 19 millimeters per year. This is known quite accurately because now we can measure this from day to day. So Iceland really sits there on this plate boundary, but you also notice that it stands out. It's really a very abnormal part of the plate boundary. This part comes on dry land. In fact, this is one of very few places on Earth where plate boundaries of this nature are exposed on dry land. So that's why geophysicists and geologists all over the world. They come to Iceland to do important research. There are only very few places where you can do things like that. So Iceland is the heaven for geosciences. So you notice also that Iceland sits on this platform on the ocean bottom. This platform is there because there is exceptionally high volcanic activity in this part of the plate boundary. And this is what we call a hotspot. Iceland is a hotspot and has an unusually large number of very active volcanoes. We have, in fact, on the dry land, we have about 30 volcanic systems that are all quite active. Most of them are dormant at the time being, but some of them are really showing signs of unrest. And they erupt every so often. On average, we have a volcanic eruption on Iceland about every 2 or 3 years. The latest eruption was in 2014. It was a very large eruption in central Iceland that you may be interested in. Okay, let's have a closer look. So here we have locations of earthquakes located by our very sophisticated local network. There are about 50 or 60 seismic stations on land here that are recording earthquakes continuously, and a system to locate the sources of all these earthquakes. And each dot here on the map, the red dot, is an epicenter of an earthquake. And this really delineates where the plate boundary goes through Iceland. You also see some yellow stripes here. These are the volcanic systems. They usually contain a fissure swarm and a central volcano. Central volcanoes are shown with circles here, and the fissure swarms are yellow. So together, these red dots and the yellow stripes, they really paint out the plate boundary as it goes through Iceland. And the arrows you see, these are the movements of the plates away from the plate boundary, and the relative movement here between east and west is 19 millimeters per year, as shown here. So, well, these red dots show earthquakes in an 11 years period from 1994 to 2005. So there is a lot of small earthquakes, and so don't despair. This is not really a terrible news. It is mainly reflecting the sensitivity of the instrumentation. These seismographs that are recording this are extremely sensitive. They show everything that happens around them, and a lot of very small earthquakes. So this map contains earthquakes down to magnitude 1 or even magnitude 0 in some cases. And that is a very small event. So most of these events are quite small. So at the same time, these show an overflying aircraft. So whenever you fly across one of these stations, we are bound to see it. The seismograph shows that as well. So you also notice that the Reykjanes Peninsula, that is the southwestern peninsula here, contains this plate boundary. The plate boundary runs along the Reykjanes Peninsula in the southwest, which is, of course, close to both the Reykjavik metropolitan area that contains about half the population of Iceland, and also the Keflavik airport. So let's try to get an idea of the rate of activity. Here we have an earthquake map, another earthquake map, and this only shows the earthquakes happening during one normal year. It's 2018, which was nothing particular. This is a year where nothing particular was happening. So you see there are hundreds and thousands of earthquakes happening in a quiet year. And most of these earthquakes are unnoticed. The population doesn't feel anything, and it's only picked up by the instrumentation. So if we now focus on the Reykjanes Peninsula, that is where most of us are living close by. Here is the Reykjanes Peninsula, and also here we have the earthquakes of 2018, just 1 year harvest of earthquakes. So, and you see Reykjavik up on the at the edge of the picture here on the right, and you see the Keflavik Airport on the left here on the peninsula. These areas, these important areas, they are located at about 20 kilometers distance from, or 15, 20 kilometers distance away from the plate boundary. So we are sitting here in Reykjavik and Keflavik on the North America plate. And this plate is moving with respect to the other plate, and this movement builds up stress in the crust on the plate boundary, and this stress is what drives the earthquakes. That's why we have earthquakes. When the crust can no longer take the stress, it ruptures, and this rupture is what we call an earthquake. It sends out waves in all directions, so we feel these earthquakes if they're big enough for that. During this particular year of 2018, very few earthquakes were felt in the inhabited areas. The biggest earthquakes, you can see them, the yellow dots on the right side of the peninsula. These were magnitude 4 earthquakes that took place on one of the faults in that area. And this is also the area where the largest earthquakes take place on the peninsula. And you see that there is not too much of that on this. So what about the history? If we look further back in history, this is another map of the peninsula showing historical earthquakes, the largest events that have taken place during the last 100 years or so. So you see, they also paint up the plate boundary, and also you see the biggest earthquakes in the eastern part of the peninsula. We notice the lake Kleifarvatn in the middle of the picture. The Kleifarvatn sits right on the plate boundary, and it seems to divide this plate boundary in two, and that seem to behave in different ways. West of Kleifarvatn, we have the biggest earthquakes. They may get close to magnitude 6, but rarely go above magnitude 5.5. On the east of Kleifarvatn, the crust is a bit thicker and stronger, and therefore the stress can build up to a higher level. And that also means that the biggest earthquakes are produced, and they are not quite as common, but they tend to be bigger. So bigger stress is released in those earthquakes. So there is some kind of a division between the different segments of this plate boundary. And the general rule is that the further west you go on the peninsula, the smaller will be the biggest earthquake. So the biggest earthquake in the westernmost part of it, they tend to be, well, they rarely reach magnitude 5 or go a bit above magnitude 5. And the magnitude 5 is not likely to cause any damage unless you are really right there. So you see Keflavik and the Keflavik Airport right there. It is close to this less harmful part of the peninsula. In Reykjavik, on the other hand, we are closer to the eastern part, and where the biggest earthquakes tend to take place. Now, the activity along this plate boundary tends to come in episodes. So there are episodes usually of a few years duration where the whole plate boundary seems to be activated. We had an episode like this in the 60s and 70s last century, and also around 1930 there was an episode like that. And these episodes involve the whole plate boundary from west to east, and including the area of the big earthquakes. Now it seems we are really experiencing a unique thing, because there is clearly an episode like this in progress on the peninsula, and it seems to have started in January this year, or possibly in December last year. And since then, there have been numerous earthquake swarms on this plate boundary, and some larger earthquakes. The largest one in this sequence so far is the one that happened last Tuesday. It's Thursday now, so it's only two days old, and we still have quite a lively aftershock sequence going on from that earthquake. This earthquake had a magnitude 5.6 and was felt quite widely in this part of the country, over a large part of the country, in fact. And but it did not cause any significant damage anywhere. It is not really big enough to do that. So we are in this sequence. We note, however, that the eastern part of the plate boundary, or the peninsula, has not participated in it yet. So that is the reason why we have to expect in the future, meaning in the next months or possibly years, we might expect a larger earthquake in the eastern part of the peninsula. That's further away from Keflavik. It's closer to Reykjavik than the present activity has been. So let's see what this year has been like. Now we had the 2018 for comparison. This is 2020. And you see, well, you can just get a glimpse of the Kleifarvatn Lake there in the center of the peninsula. And you can see how the western part of the peninsula has been extremely active throughout the year. There are numerous earthquake swarms, each one lasting a few days, and they come again and again. And so this is really what we have to live with these days. A lot of these earthquakes have been felt in Reykjavik. People in Reykjavik have, I think, never in 1 year felt as many earthquakes as this year. So we are clearly in an active period. But you also note that the eastern part of the peninsula has been very quiet, suspiciously quiet. So this is really a comparison with earlier episodes of this nature. We are still missing the big event in the east. So it has to be taken as a fair possibility to have that. And you see the biggest event so far is the one right in the middle of the picture, the big red blob there. That was the magnitude 5.6 earthquake on Tuesday. And this sequence is still going on in the area. So these are the earthquakes. But what is a bit interesting in this, that all this activity that's so far has happened in only 1 year. And usually in the previous episodes, this has taken place over a period of 6 or 7 or even longer years. So what could be the reason for this? Why is everything happening so quickly now? The answer may be that this time we have detected injection of magma from below within this zone. This zone is also where the volcanism is the most intense. So, and we have not really seen that much before, that magma is coming into the crust. So there is a possible crosstalk between the volcanic systems and the plate boundary in this case. So we have injection of magma right in the Grindavik area. They're close to the Blue Lagoon, and the Svartsengi power station sits right there. That is where the ground started uplifting in January. On the 20th of January, suddenly the ground started to rise, and it rose for a month or so, about 10 centimeters, and then we'll see more of that later. And since then we have had more episodes of this nature also. Now lately in the eastern part of this active zone, just west of Lake Klevarvatn, west of Krýsuvík, so now the landmark right there. And this seems to be still in progress. So it seems that the volcanic systems are coming to life again after a very long time of quiescence. So we note that the volcanic activity on the peninsula, even though on a long-term basis it is relatively high, it is also episodic on a much longer time scale than the earthquakes. In fact, we have on this peninsula apparently active periods of 200 or 300 years, and then followed by a quiet period of maybe 500 to 800 years. And we have been in a quiet period now. The latest eruption on the peninsula occurred in 1240. In the year 1240, there was a sizable eruption, and it was the end of a period when quite a number of eruptions occurred on the peninsula for the previous 300 years at least. So no eruptions since then. So it has been a burning question now for decades. How do we detect the beginning of the next active period? Because the volcanoes are definitely not giving up. They have a purpose here because they fill in the gap between the plates. So if the plates go apart, the gap is filled with the lava that is produced by the volcanoes. So we desperately need more material to fill in the gap, otherwise the peninsula would sink. So this is really the situation now. We may be at the beginning of a new volcanic period that may last a couple of hundred years. We may also have a few hundred years to wait for it. This is one of the most important questions here now. Is this what we are looking at, these earthquakes and inflation of the volcanic systems? Is it the beginning of the next active volcanic episode on the Reykjanes Peninsula or not? So every day now almost for this year has been filled with these questions and is providing new information, new evidence, showing new behavior that we haven't really seen before. So it's a very interesting period to be a geoscientist on the Reykjanes Peninsula right at the moment. The important thing is here to keep in mind, even though we might have an eruption or earthquake, that they're probably not going to be very dangerous. The eruptions on the Reykjanes Peninsula tend to be relatively mild lava eruptions. Explosive eruptions are very rare in this area, this part of the country. So a lava eruption is, it's a quiet affair, producing just lava flows. Lava flows can, of course, make damage, but they very rarely threaten life. So we may be up for a spectacular show of fireworks, but and possible consequences like gas or things like that. Not ash eruptions are not common here, but lava flows are. There are no really big eruptions known on this peninsula for a very long time. So a relatively small, peaceful lava eruption is the most likely exposure of this force of nature. And keep also in mind, the earthquakes are most likely going to be quite small. Even though there will be some shaking, it's unlikely that it will cause collapsing houses, and casualties are probably not going to be happening. So this is the nature of this activity we are looking at, and just to demonstrate one of the appearance of the data that we are getting all the time to monitor what's happening. This is monitored from day to day. And one of the methods used here is to use satellite radar images of the area. And if you take two of these taken subsequently, then and you subtract one from the other, you see the change that has happened to the landscape. And that is how we detected the uplift area, the inflation of the volcanic system in the western part of the peninsula in January. So this picture shows you this bullseye pattern there. It really shows you the uplift. It's a bulge that is formed on the surface of the Earth, with a center just west of the Blue Lagoon in Svartsengi. And this uplift, well, it is caused by magma injection into the crust from below. Magma is coming into the crust. It is forming a layer within the crust at the depth of about 3 to 4 kilometers. You can see that from the shape of this bulge, and then you can from the volume of this bulge, you can estimate the volume of the magma that is injected. And what we have seen since then is more of these events, these injection events. And even if you take all the volume that has been injected into the crust, and if that was all delivered in one eruption to the surface, it would still be a small eruption. So we are not talking about anything catastrophic, at least not yet. And we will probably know before it develops into that kind of activity. So if you take a profile across this bulge, that is what you see below. You see these curves there. These are curves taken across this bulge at different times. You can see the blue curve shows the beginning state of this, and then it was uplifted, and you go to the green color to show what happened 60 days later, and 100 and 120 days later, the shape of the bulge was like the orange curve shows. So you can see the growth of this bulge, and you can estimate how much magma was being pumped into the crust per time unit. So this can all be measured quite accurately. And if you just take the top of the bulge and find the maximum uplift, you can plot that as a function of time. That's what you see on the left. This is a curve showing the maximum uplift at each time. The horizontal axis shows time, so it's the beginning of the year at the beginning of to the left, and then time goes to the right. So you can see how the area was uplifted in January and February into February, and then it stopped, and there was a small subsidence occurring for a few weeks. Then injection started again. So there was another volume of material injected there, and this has continued since then. There have been 3 injections into this particular area, and now we are monitoring an injection into a different area near the eastern end of this activated zone, near Krýsuvík. So that is the state of affair now. And if you look at this is the same kind of data. showing 2020, and the pink periods in here show the uplift periods, and then the subsidence period in between. So these pink stripes, they show the 3 different injections of magma at Grindavík or Svartsengi, Blue Lagoon, and now this part has become inactive, and now we see similar thing happening further east along the plate boundary. So it's interesting times where the geoscience community is following this very closely. Every day brings new surprises and new discoveries, and one of them, one chapter in this continuing story, happened on Tuesday when this large earthquake took place. And considering that this has been going on for most of the year, it's rather unlikely that this is the end of it. And but we are monitoring this quite thoroughly, and I'm sure you will see news about this in the newspapers and on the radio, and so everybody is following this story. So, well, I would like to point you to a web page. One of the special conditions in Iceland here is that the monitoring of the hazards and everything that happens in the crust of Iceland is put on web page, and there is a web page of the meteorological office, Veðurstofa Ísland, and this web page is very good. It's very user friendly. You can really see the whole thing there. If you play with the website, you will find a lot of information. There's an English version of it, and so you can follow this continuing story if you dig into it by yourself. This is one of the special conditions in Iceland that the scientists are really sharing all their data and ideas with the public, and so the public can really follow everything. There are no geoscientific secrets in this community. So if something dangerous happens, you will hear about it on this website. So, and you can see the earthquake page, find out what earthquakes happen every day, and so you can really do the monitoring by yourself at home with your computer. So I think that's enough for the time being, but keep in mind it's a continuing story. There are probably not going to be any life-threatening developments of it, at least not yet.